OCP provides that governance framework that allows all of these companies to work together. So Supermicro and AMD and NVIDIA and Microsoft and Google and Meta to all come together and work under the governance framework to produce common specifications that then the rest of the industry can take and adopt pieces of it or parts of it or all of it, depending on your infrastructure needs.
Hey, hello everybody, and welcome to this new Stacktalk. Today, we're going to be talking about open infrastructure, all data centers, efficiency, new form factor for data centers. And for that, we have a great speaker today. Steve Helvie is the VP of Emerging Markets of the Open Compute Project, a project that has been working in a lot of new form factors and technologies for accelerating the scalability in data centers. So, Steve, thanks for joining today, and I think this is going to be a very good conversation.
Thank you, Jose Miguel. Always good to chat with the folks at Whitestack and yourself.
Thank you very much. So maybe something that we can start with is with a general description about what is the purpose of the Open Compute Project, how it was born, what are the key objectives, so that people that are not familiar with the concept will understand a little more.
Sure. At the heart of Open Compute, we are essentially an open source hardware foundation that spans the entire aspect of the data center. It was started in 2011 by Facebook or Meta, and at that time they were outgrowing their infrastructure quite quickly. And so they decided that they needed to design their own servers and their networking and their storage devices. And so they worked directly with a manufacturer to do that. Now, a big company working directly with manufacturers to design something was not new. But what happened at the end is when they designed their servers and their networking and their storage, they decided to open source them and provide those specifications to the broader market so that they can improve upon a typical open source community type of model. Again, we're not taking IP, but we are providing a governance framework for those specifications to come in so that people can improve upon those specifications. And over the last 10 years, we've grown now to over 300 plus companies across the IT infrastructure and spanning all kinds of areas within the data center. So you have data center facilities itself, so the physical infrastructure, specifications around that, specifications around liquid cooling, chiplets, and even the traditional areas of rack and power storage and networking have really proliferated over the last 10 years. So it's a pretty big organization, and we're doing some great work with over 100 specifications coming in throughout the year over the last several years.
So I think that the interesting part of what the OCP has done is that by creating those open specifications, you're allowing any other company that is not in one of the hyperscalers, but maybe a telco, to adopt some of those specifications to build more efficient data centers, right? So yeah. What has been the market response about those open standards, open specifications that you have released to the market?
I think that you've seen over the last several years this interest in working together more collaboratively, even in the proprietary world. So the growth of community-led type of innovation instead of working in a silo or a proprietary area. There is a pace or a speed of engineering that you get when you work together collaboratively. That is one area that we see. So one of the primary goals of Open Compute is to take hyperscale-led innovation, like you said, that many of the hyperscalers are in Open Compute, but take that innovation to the broader piece of the market. So you say, well, what has been the reaction? On the reaction of the adopter side, or people that are acquiring this type of technology, the change in infrastructure about being able to deploy at scale using more white box or generic ODM type of servers has grown exponentially. So double-digit growth over, say, a traditional classical legacy type of hardware. So that interest in using open source or open connectivity type of devices has grown exponentially. The interest in if I'm a manufacturer, participating in that, because most companies want a multi-vendor supply chain. So they want really to have multiple suppliers, but they would prefer those multiple suppliers to be working off of one or two types of specifications. So the difference is between a legacy model. Let's say I go out and buy a couple different legacy servers. I may have different management tools, different spare parts. Within Open Compute, you now have one specification and you have multiple suppliers working off that one spec. So that makes you a great deal more efficient when you're deploying that infrastructure into your data centers.
It's something that we have experienced in our projects. We have been working with some operators deploying some OCP form factors, so servers, for example. We use a form factor with AMD processors. And that has demonstrated a huge efficiency, not only density, but also in energy. We are seeing that in practice. So things like that are not only in the practicity of having a supply chain, but also in efficiency, actual efficiency in the facilities, is something that is general in other designs too?
It is. It's one of our core tenets. So we have 5 core tenets within Open Compute. And that is one of them. So anything that comes through the foundation needs to exhibit openness and scalability and have an impact, as well as sustainability. So those type of designs, there's this inherent interesting thing that happens when you work in a community, is you have this drive for simplicity. How can we make things more simple? What can we get rid of? So in a classical traditional IT model, you may have a company that adds more things and adds more functionality and more things that may or may not be needed in order so that they can serve the broadest market. So what do most people might like? Within Open Compute, we strip all of that out. So that allows for a lot more efficiency. So to give you one example, the OU height, or the height of the server, may vary. And it allows for a better airflow. The rack is slightly modified to where it allows you a great deal more density in that rack, but you have the better airflow and the fan usage. All of those things lead to anywhere between, say, 10 to 50% more efficient on the energy usage within that rack itself.
And for a telco, those two aspects, density, space, and energy, is extremely important, not only by the cost, because of the cost of the energy, but it's the cost of opportunity, because they don't have more capacity in their facilities. So there is a constraint in terms of space and energy. And the challenge is how a telco can deploy as much compute as possible on those conditions. So that's when I think power and space efficiencies are key. And assuming that in the data center, in the large data center, in the regional data center, in the national data center, efficiencies are going to be increased with time. So there is a number of questions about how could that efficiency be translated to the edge. That is a different story. So the edge in this region are sites with DC power, not AC power, no UPSs, but batteries. So it's a telco facility. So what is the OCP approach for those environments that are more telco design?
In the more central office, so one area on the CU and the DU as an example, we've had several members create shorter form factor servers that allow for dense deployments in non-classical data centers. And so we've seen a lot of these edge type of devices cater to these more unique data center or central office environments. I do see the rack densities moving up considerably in both the edge deployments and the main data center deployments. When I first started Open Compute, I would see an average of 3 to 5 kilowatt rack type of deployments, even at the edge. And now it's not uncommon to see 12 plus kilowatt racks being deployed in these areas. It's only going to get more dense, Jose Miguel. And what I think is going to happen is you're going to need, as you get more dense deployments, one way that you're going to have to look at this is through the different cooling methods. Anytime you get above, say, 15 kilowatts per rack, air cooling becomes very difficult to cool that rack. So as these telco operators provide AI services at the edge, you're going to have to look at, how do I cool my rack? Is it immersion? Is it cold plate? Is it rear door heat exchange? And everyone in the industry is saying, well, which cooling method is going to win? Is it going to be as immersion? Is it going to be cold plate? And the consensus within the community, across our community at least, is that you're going to have a company that has every one of these cooling methods deployed based on their workloads. Some workloads they'll be able to run at just typical air. Others are going to need immersion. Others are going to need cold plate, and others for rear door heat exchange. It could be based on the workload. It could be a cost factor based on where they can deploy that particular workload. So the central office is going to be changing. And I know that there's an initiative in Europe happening called Central Office 2030, and they're tackling this, and sustainability and energy usage is one of the big areas that they're looking at. And we hope to partner with them. And Deutsche Telekom is one of the key areas or key vendors or operators that are leading that area as well.
Cooling is a very interesting topic, particularly because most of the telco facilities in the region are old constructions, right? So they have already a standard cooling system for the power densities that were used before. So is liquid cooling something that could do something here? So maybe be specific to have a solution for cooling just one or two racks within the room in a more efficient way? Is OCP working in something about that? Or not necessarily?
Yes, immersion tanks are as well. We have members that are putting together an immersion tank that you can put just about anywhere in the world. So you can drop, it could be 40 servers, it could be a half rack of 20 plus servers in an immersion tank to provide those edge type of use cases. So I think that right now, rear door heat exchange is the easiest and fastest way to get advanced cooling, and then it becomes cooling to the chip, and then immersion. So of those, it seems like rear door heat exchange is first because it's the easiest, and people already have that set up. They just need to put a door exchanger on the back of the rack, and then the second would be the liquid to the chip, and then third would be immersion. But the immersion has some very unique use cases that I think are very applicable to the telco environment, especially providing climate-wise, as well as environmental. So there could be not only the temperature range, but also in heavily polluted areas as well. Immersion has some advantages there.
Okay. Last question about edge, your approach to edge computing. So in edge, there is a need for compute, networking, storage, but also for acceleration, hardware acceleration, time synchronization, all those standard elements in the OCP designs for the edge? Yeah,
the AI acceleration has been quite interesting, as everyone has experienced over the last 12 to 18 months. Within Open Compute, we have an AI strategic initiative that's looking at the IT infrastructure inside the rack, and then the IT infrastructure in the physical location, and then other things such as the power and cooling that goes around with the memory and the chip itself and the interconnects that take place. So imagine that you have the outer layer here is the physical infrastructure. How do we optimize that for AI? And then inside you would have memory, interconnect, and then the rack and the power. This all goes into the accelerator, including the time appliance. There are open source time appliance cards that help for synchronization. Chiplets are also going to take in place in that. We have guidelines around the GPU accelerator modules that are coming around. The domain-specific architectures that are being developed within the community are tackling AI at a very, very quick pace within Open Compute, being led by the hyperscalers and the top GPU-oriented members that we have, AMD, NVIDIA, etc. So all of these folks are working very diligently. And the good thing about open compute is, as I look at this, everyone needs a way that they can work together. Of course, I can pick up the phone and try to work directly with, say, someone like NVIDIA or AMD on something. But you need that governance framework. What can I share? What can I retain? OCP provides that governance framework that allows all of these companies to work together. So Supermicro and AMD and NVIDIA and Microsoft and Google and Meta to all come together and work under the governance framework to produce common specifications that then the rest of the industry can take and adopt pieces of it or parts of it or all of it, depending on your infrastructure needs.
So OCP focused initially on the data center, now on the edge. There is something else that comes after the edge. So it's the radio access. I heard that yours are also working on some radio projects, right?
This is new. A year ago, Meta contributed the specification and the design files for an open radio unit catered for 5G platforms. And that project was called Evenstar. So if those in the audience may have heard of the name Evenstar, that was a Meta focused work that has now been transferred to the Open Compute project. So over the last few months, Jose, we've been working and having discussions with operators, with radio manufacturers, with software companies, with testing labs to find out, based on this specification, what can be improved, how can we take this entire community forward? So one of the first things that we did is develop project leaderships. Is the way that OCP works is we have work streams or projects that are led by volunteers in the organization. So volunteers from Bell Canada and the former CTO of Spirent have signed up to lead this project. And over the last few months, we've been having monthly calls with the community, which are completely open to anyone, to gain feedback on where the current specification is now, what are the family of SKUs and the use cases that we need to address moving forward. Could be private 5G, could be small cell, could be some other use cases. But the goal is to really drive down the total bill of materials cost for a radio unit that everyone can use instead of spending tens and thousands of dollars on a radio unit. We want to get that cost very, very low and do what we have to other areas of the data centers to strip out everything that's not needed, give everyone a particular use case radio unit that they can use at a reduced cost through a multi-vendor supply chain. So having multiple vendors from which to choose to buy that radio.
So I imagine the OCP role here is to create a specification that will fulfill most use cases and industry standards and so on. So that's manufacturing correct. Will be made by partners, by members of the community, right? That's
right. Yeah. And for example, those in the audience may or may not be familiar with quite a significant RFP that's out now through the U.S. government around funding for developing an open radio unit. Part of that RFP, Jose, means that we need to have manufacturing, and that manufacturing needs to be diversified. So some of it needs to be in a U.S. type of design manufacturing, and then some of it can be in other regions. But I think the goal of the Evenstar project, and that I would encourage everyone, is to get involved in the project, to listen in and provide feedback. The great thing is you can provide your feedback up front about what would be best for you and what you would like to see in an open radio unit that then the community can then develop and go have manufactured either locally or regionally, depending on your needs. So get involved early, provide your feedback, get early in the product life cycle, early in the roadmap, so you can have these discussions with folks like Bell Canada, and so you can leverage the other things that they're working on, and so that you don't have to go it alone. You can solve a common problem together.
I like that you mentioned manufacturer diversity. That's, I think, is critical, because the first question any operator will ask is, which company is producing this? What are the risks of buying from them? So what you are doing is very interesting, because you are not only defining a product, but creating a framework where different manufacturers can compete following the same guidelines. having the same standard. And that will provide, as it happens today with compute, right? So we can buy OCP servers for a number of manufacturers that will give us a lot of security that this is reliable. But that's very good. I think it would be good to try to get some of the Latin American telcos getting closer to the OCP project. What would be the best way to do that? What are the ways they can participate in the initiative?
So I would agree that the Latin American market could benefit a great deal from some of the work that has already been published, and hopefully be involved in setting the direction for what would be most valuable to them on the areas that we're working on. There are really three ways that I think that if I'm a company, I would look at OCP. The first is to just leverage what we have already done. It does not cost anything to download our materials, download our specifications, look at our online presentations from our members. So you can go to opencompute.org and search the contributions database, search our past events. All of our content is free. That is the first thing to do, is just consume and see what is out there based on your specific interest. The second is get involved. Every one of our projects has a mailing list. So you can join that mailing list. We have monthly calls. Those monthly calls are recorded because not everyone can join the monthly calls when they're happening. Everything is recorded and posted online. So when I say join the mailing list and listen in the calls, that doesn't mean that you have to contribute. You can just listen to the dialogue, understand what people are talking about. And then the third area is getting involved. Getting involved could be a few different ways. You could attend our global summit in San Jose, California in October, where we have over 4,000 people for the entire community. And you can see the entire supply chain and what everyone is doing within Open Compute across every one of those projects. It could be making a contribution. Perhaps you have a thought leadership piece or an idea that you would like to share. So the way that specifications develop is that if you're a company and you say, well, I have this common problem. I'm going to share this with the community. Is anyone else interested in working on this together? And you will find the people that they call fellow travelers or companies that have the same thing that they would like to work with you on. And that's how working groups form and specifications are developed. So first, listen and look at what is already out there. Second, join and see and get an idea of what's happening within the project. And the third is attend and contribute. And if you have any questions at all, feel free to reach out to me and I'm happy to steer you in the right direction, I hope.
And same way, if any attendee to this conference, to this conversation wants to know more, Whitestack is also happy to drive the path to getting close to the OCP project.
Yeah, and I would highlight that your question was, well, how do I get involved with OCP? But I think for locally, your team has been around OCP for several years now. So you understand how things come to market. You can show people the actual hardware and you can explain it in a POC type of environment and let them get their hands on it and understand it. So we're very fortunate at OCP to have local partners like yourself that can execute and really show people up close and in person what the hardware is like. So I can tell from the project side and how things are moving at a macro level, but really when it comes to how things are going to work and deploy and whether it will work in your environment, your team is the best local resource.
Well, and the customers are happy. That's the most interesting thing. So they are seeing the benefits and extremely happy with the projects we have developed for them.
Yeah, and Jose, I just tell people, just try it. I mean, everyone has a lab environment where you're testing out new things. So put an OCP box next to your traditional box and try it and see if it meets your expectations. And hopefully it does.
So Steve, thank you very much for this conversation. Good news is that you are also presenting in our upcoming event in September, the Open Telco Cloud Summit. So Steve is going to be presenting there in Mexico. So if you want to continue the conversation with Steve, please join us in the event. And for sure, there will be good content in that event that we will be sharing with all the people here in Latin America.
And I'm excited about the event in September, and I am very excited about the potential for OCP adoption throughout Latin America. And I'm extremely excited about what the telecom operators can benefit from the designs that have already been contributed and that are in the pipeline.
Excellent. Thank you very much.
Thank you, Jose.